How do I get back?
Use this.
Ah,
And you can continue to use this.
that's what I'll use. You can use a high-density bat. You could also use a high-density foam in there. A high-density foam is going to give you somewhere from 6 to 7 R factor per inch. So in a 2x4 wall, you could get up to well over R20, R20, 22 or 23 to increase your R value on a home. And I'm thinking it's sometimes difficult to ask a builder who has stock plans or is involved in some sort of complex that's already been permitted to start changing the design of the home. So we look for ways to use the existing plans. You can't take a 2x4 wall and put it up to a 2x6 wall and not take away from interior space, not take away from hallways. So we're aware of that. So you could use a spray foam to increase the R value. You could also just go outboard and skin the whole building with a high density insulation board. What that would do was stop the thermal bridging. When we talked about all the framing factors, every time you add wood, you take away from the R value. Not only are you taking away from the R value, you're giving a direct line of communication from the temperatures outside. If it's 0 degrees outside, it's only got to go through 3 inches of wood to start coming in and affecting the temperatures inside the house. So if you can stop that thermal bridging, if you can provide a very dense layer of insulation, you have greater comfort. You have less radiant heat loss, less conductive heat going on. So in order to increase in a 2x4 wall, you can go to an R15. You could actually go to super insulation with a high density foam, or you could skin the entire building. The other thing you could do is start spacing differently. This is actually a double wall. It's a 12-inch wall that's spaced 24 on center. The framing factor is probably well below, I think it came out to about 16 in this particular house, almost 10% less than, 10 points less than a typical home. And I don't know if you can see the detail right in here, but you have two 2x4 walls separated by about 7 inches and just a small plate or a small plywood gusset. So you actually have a 3.5-inch cavity insulation and 7 inches of cellulose insulation that provides the thermal break, and then another 3.5. The loads on these homes, this was actually taken from one of the zero energy homes that actually scored below 0. So they're doing as many passive things as possible to reduce the heating load. They used a small air source heat pump with one head to heat a 1,400 square foot house. No centralized heating plant, no air conditioning. They don't need it. So when you're looking at insulation, it's not just the straight R value, it's the straight U value. It's trying to get away with the thermal bridging, and it's also the quality of the installation. I don't know if you can see these pictures here. The insulation has been stuffed behind this pipe, been stuffed behind this outlet here. Every time you compress insulation, every time there's a void, 2 things happen. You degrade the insulation. You don't have that thermal protection. You're also out of compliance with the thermal bypass checklist. That can be a problem. You're not going to get Energy Star rated. You could have a very efficient home and still not get Energy Star rated. But if you want the utility support, if you want the marketing cachet, you need to be in compliance. I didn't provide a slide with a lot of technical information, but I'm just going to give you some numbers that I've worked up right off the top of my head. If you had an R13 wall versus an R19 wall, simple math, what's the difference? It's R6. It's a 46% increase in the R value. That's only in the cavity. If you were to convert those numbers, R13 and R19, to U factors and then do a U value or a U area, about 100 square foot area, the math changes considerably. For an R13 wall, you have a UA of 0.085. I'm reading this. It's not coming off the top of my head, folks. And R19, you have a UA of 0.079. That's an 8% difference. By going to an R19 wall, by going to a 2x6 wall, you're not gaining, half, again, what you've installed in the wall. You're only really gaining about 8% more. So in this house right here, this was another Zero Energy Home participant. The Zero Energy Challenger is looking to get people below a HERS 35. People got carried away and they got below zero. I don't have a problem with that. This was one of the participating homes. It scored in the mid-20s. But they used a typical 2x4 wall and then skinned the entire building. They didn't have the interior room to go to a 2x6 wall. But this was beneficial because if you take a look at a typical wall assembly, if you take a 2x4 wall and then skin it with a high-density foam board on the outside, and you compare that to an R19, they're basically equal. This is an R19 wall right here. Whether it's not 2x6, it's 2x4 plus the rigid. And you take a look at the U values, 0.058 versus 0.079. It's a 36% increase. You're almost on par with what you thought you got by moving up to a 2x6 assembly. So it's really, the quality of installation is the last point. And how effective is that installation that you're putting in? You've got a lot of bunching up in here. Spray foam, you're going to seal the house. If you fill the full bays, it's going to work its way around all of the pipes, any penetrations. The same is true with cellulose. If you use a hybrid system, in fact, I'm looking at the guy that rated this home. Paul, did they use a flash and bat in here, or was it?
Mike did that one.
Mike did that one, and Mike's not here right now. But you could flash the entire bay, just
Dave,
like.
one thing you should mention in this regard is how the different insulation technologies will influence air infiltration.
Speak up.
How the different insulation materials will influence air infiltration and leakage.
All right, I'm covering that in a little bit, but I'll touch on it right now. We're going to deal with whole house infiltration, exactly how much air can move in and out of the house naturally on its own. Fiberglass is, or filter glass as it's sometimes called, can't stop the flow of air. Cellulose, dense packed cellulose, has some ability to stop the flow of air. If you're looking at a spray foam, that's going to seal up every crack. It's going to stop air from moving, which is a good thing. You don't want air moving in and around your house, especially inside of the cavities of the wall. This technique, if you tape and seal every seam, has a very profound effect in reducing that infiltration. But there are a lot of strategies that you should actually talk to your HERS rater. Where to put the insulation. We'll talk about that shortly. Not so much how. I'm a firm believer, and you can see it in my own utility bills in my own house, if you air seal the house, it's more important than insulation, first and foremost. I have an old 1950s era Cape. I have 2x6 for roof rafters. How much insulation can you get in there? But if you seal it up very, very well, you can really reduce your energy bills. So insulation, we could go on and on and on. This is a general program overview.